Welcome to Spring LIB.
All right, so we've got a couple of alkenes here, or the same alkene twice, rather, reacting in two different conditions. First, BH3 in THF, followed by hydrogen peroxide in sodium, or with sodium hydroxide. This is known as hydroboration oxidation. And hydroboration oxidation adds an OH group across a double bond, and it does it in so-called anti-Markovnikov fashion. What that means is that it adds the OH to the less substituted side of the double bond. So here there's only one carbon attached, here there's two, so this is the less substituted side. So we'll get the same exact thing without the double bond. And we'll get an OH attached here. Okay. Now the interesting thing is there's still some stereochemistry to this. So you may have also realized that if we're going to add an OH here and we're going to get rid of that double bond, that also means we'll have to add an H here, right? There wasn't previously an H, but there is now. And the rule is that the OH and the H always end up getting added to the same face, right? So if we were to add it to that particular face, then this methyl group would be forced to become a dash. But it also could have been the case that we added the OH to the bottom face as well as the H to the bottom face, which would make this methyl group become a wedge, right? So either of these are the correct product, and we'll actually get a 50-50 mixture, or a racemic mixture of these two products. Okay. Next, we have the same substrate, but we're reacting it with acidic water. Okay, and acidic water will add in a Markovnikov fashion, which means the OH gets added to the more substituted carbon instead of the less substituted carbon as last time. So the double bond will be gone. Right. It's not a great wedge there. And we'll end up with an OH here. And because this proceeds via a carbocation intermediate, what ends up happening is that at some point this carbon is flat. The OH can add either to the top or the bottom. So we get a mixture, again, of products. We get the version where there is a wedge to OH and a dash to the methyl group. And we get the version where there is a dash to OH and a wedge to the methyl group. Either are valid products, and some people may simply draw it as leaving this as a wedge, but then showing both the OH and the methyl group as lines to indicate that both of these stereoisomers are present.